Okay, this is a solution to introset 5 problem number 1. We want to discuss this a little bit. Given the depth and dimensions of a rectangle, we want to find the force. By depth we mean depth of water, in this case, above the rectangle. We want to find the force on the rectangle. Now, a common solution that I saw in class today, after having been through this stuff for a couple of weeks, was, well, we find the pressure, that's rho GH, and then we multiply that by the area to find the force. Now, that's okay, and that would be a full credit solution if I didn't specify otherwise. But on the introset problems, I want these reasoned out from first principles the way they are in the given solutions. So, this would be a half credit solution if I specified that I want to see the reasoning and I want to see it reasoned out from first basic principles. So reasoned out, we know that if there's a rectangle here and you've got water to some depth above that, and I'll just kind of indicate that by this dotted line, or this dotted parallelepiped, this dotted figure. The rectangle has to support all the weight of that water. Gravity's pushing down, the water is not going anywhere, so this rectangle has to be supporting that water. Whether this is a rectangle of some material, whether the rectangle is just the water at this particular depth, it's going to be the same. So what we have to reason out is the weight of the water above this rectangle. So what's the weight of the water above the rectangle? If the dimensions of the rectangle are length times width times height, the volume is length, well, I got a script L, so I'm going to use H, and then times L times W. Okay, L times W can be regarded as the area of the base. We multiply that by the altitude, we get the volume. So that the mass equals density times volume, which is then rho times H L W, and the force that we need to exert to support that mass with gravity acting downward, we have to exert an equal and opposite force. So the force equals mass times gravity, where I'm just using M for mass. I wrote out the word here, but we'll use M for the symbol. So the force is mass times the acceleration of gravity. And that works out very easily. I'm going to go off camera and write in the numbers that I see here, and then we'll just kind of summarize the solution.